Running can be conveyed as a sport. People in the Olympics run a certain distance and try to run that distance in the least amount of time. The quickest they run, the lower their time is, and the higher their speed is. And when there's speed, there's always acceleration, even if it's zero. Here we have Emily. She wants our help for her to be able to run long distances while keeping a close speed the whole time. When running, you tend to wear clothes that help you have a higher speed. You don't wear tight jeans and a sweater because that would make it hard to run because it decreases your stride length and you overheat. You would wear more loose clothes or something easier to move in like shorts and sweatpants, t-shirts, etc. Something very important to wear is sneakers. You tend to wear something more comfortable, not tight and stiff. Something that you could actually bend instead of something that keeps its shape. You want to have as much friction as possible. In the Olympics and other sports, they wear cleats that usually have metal in them, which digs into the ground, track, or field and helps you move faster. If you're just going for a run like Emily, you're going to wear sneakers that usually have rubber on the bottoms. This is just like a car driving on the street because it's rubber on concrete. Something that also has to do with the force of friction is your mass. This has to do with inertia and how an object at rest wants to stay at rest and an object moving wants to stay in motion. For our first physics problem, we are going to find the force of friction by wearing rubber sneakers on concrete. We are going to use the formula force of friction equals mu times the normal force. And in the end, our force of friction will be 565 newtons. Now that Emily has a greater force of friction and more comfortable clothes to run in, she is ready to run for a better acceleration. Let's test it out. For our second and final physics problem, we are going to find the acceleration using the formula acceleration equals the change of velocity over time. And our final answer, which is acceleration, will equal to 0.0032 meters per second squared. Emily did a great job running. With a great acceleration and a good time, Emily was able to stay at a good pace like she always wanted to.